For our last question in Module 6, we're going to deal with an inequality. In the first two questions we had equations. We want to solve the inequality 2 plus x over 3 minus x is less than or equal to 1. Typically when we solve inequalities, we expect a big range of solutions rather than one or a few certain values for x. Okay, so again, we need to stare at our inequality this time and think about which method we'll use to solve this. And when you look at the left-hand side, we see a fraction, right? And so maybe the natural thing to do is to get rid of that denominator and multiply both sides by the 3 minus x term. And this is the way to do it. But it's trickier when you work with inequalities, because remember that when you multiply or divide both sides by a negative number, you have to switch the sign of the inequality. And so to solve this inequality, we actually have to split into two cases. And that's when this 3 minus x term, which we'll want to multiply both sides by, is bigger than 0, and when it's less than 0, strictly less than 0. It can't be equal to 0, right? We can't have x equals 3 here, because that'll set the denominator to be 0, and that's not defined. So it's either when 3 minus x is strictly bigger than 0, or when it's strictly less than 0. So for the first case, we're going to assume that 3 minus x is strictly bigger than 0. And so what does this mean in terms of x? Well, this means if you take the x to the other side, this means 3 is bigger than x, or if you like, x is strictly less than 3. Right? And this is really important. Whatever we do the rest of this case, we have to remember that we must have x strictly less than 3. Okay. So now let's multiply both sides of this inequality by the 3 minus x. So we have 2 plus x over 3 minus x less than or equal to 1. This implies, right, so this arrow here, this funny looking arrow, means the word implies, right? So the left-hand side implies what I'm about to write. If we multiply both sides by 3 minus x, it just goes away from the left. That's the whole point about multiplying by it. And then on the right, we get 1 times 3 minus x, and so we just get 3 minus x. Right? And remember, let me emphasize that we started with a less than or equal to, and we still have less than or equal to, because we're assuming that 3 minus x is strictly bigger than 0. We're multiplying an inequality by a positive number. Okay, now this right-hand side looks much more friendly to solve, right? So we just collect the x terms together, put the numbers on the right, and then fix it up, and we get a value or a range of values for x. So this now implies if I take the 2 from the left to the right and take the minus x from the right to the left, I get 2 lots of x on the left, less than or equal to, I get a 3 minus 2 on the right. So I'm just rearranging to get 2x less than or equal to 1. And now I can just divide by 2. That's a positive number. It doesn't change the inequality. And so I get x is less than or equal to a half. Okay, so now we have to think about our assumption. So remember, we assumed that x was strictly less than 3. So anything strictly less than 3 is fine. And then we eventually got that x had to be less than or equal to a half. And so if we think about those two restrictions together, we need x less than or equal to a half. If you like, we can sort of think about this on the number line. If this is 1/2 and here is 3, our assumption was anything less than 3, not including 3, is fine. And eventually we got that x must be less than or equal to a half. So I fill in the dot because it can be equal to a half. And so basically we want the intersection of these two, the common part of these two lines. And so we need x less than or equal to a half. So we have x less than or equal to a half. But that's not all our solution, or potentially not, because we've got another case to consider, and that's when 3 minus x is strictly less than 0. So we're going to repeat the process. But now assume 3 minus x is strictly less than 0. And so this means that 3 is strictly less than x, or x is strictly bigger than 3. And I'll underline that because we've got to take note of that assumption. So then, let's go back. So 2 plus x over 3 minus x less than or equal to 1. Less than or equal to 1. So now we're going to, just as before, multiply both sides by 3 minus x. And so on the left, we're just left with 2 plus x. But because we're assuming the term we're multiplying by is a negative number, this less than or equal to here flips into a greater than or equal to when we multiply both sides by the 3 minus x. And we get one lot of 3 minus x is 3 minus x. So it's a little different here because we had to flip the sign of the inequality. But now we keep going and collect the x terms and the numbers on the right. Take the minus x to the left again. We get 2x. Take the 2 cross to the right-hand side. We get 3 minus 2 is 1. And now divide by 2, and we get x is greater than or equal to a half. Okay, so as long as x is strictly bigger than 3, we get a potential solution of x bigger than or equal to a half. So let's think about the number line again. So we have our 0, we have a half, we have 3. Now for all of this to work, we needed x to be something out here. Bigger than 3, not including 3. And if that's the case, then we got a potential solution of anything bigger than or equal to a half. But something like 2 or 1, while it satisfies that it's bigger than or equal to a half, it's not strictly bigger than 3. So we discounted such values, right? So again, we take the common part of these two lines, and we see that anything strictly bigger than 3 is a solution. So we need x to be strictly bigger than 3. Right, so that's our two cases. And we can put these together. So we have solutions. X was less than or equal to 1/2, or x is strictly bigger than 3. Any number satisfying either one of these inequalities will be a solution to the original inequality. I'll finish by rewriting this solution using interval notation, which you would have seen before. So we can write this using interval notation. Let me write or x is in. So less than or equal to a half, we write as anything from minus infinity, round bracket because we can't actually attain minus infinity, up to a half, square bracket because we include the number 1/2, together with, so this u means union, anything bigger than 3, strictly bigger than 3, so we need a round bracket because we're not including 3, all the way up to positive infinity, again round bracket because we can't attain positive infinity. So you can write your final set of solutions using interval notation in the following way.